Thank you. Thanks. So yeah, MDM, it's a thing, I guess, right? Today we're going to talk about the history of MDM, types of profiles, although I kind of skipped most of that, the MDM check-in protocol, the MDM protocol VPP, and best practices. Since this is right after lunch, about halfway through, I'm probably just going to make everyone stand up to make sure that you're awake, and also because the content is somewhat dry. So a brief history of time. 2008. Does anyone remember where they were in 2008 or what was going on in the world by any chance, other than Tom Bridge? I saw that yawn, Luis. I'm only 1 minute in, dude. Israel invaded the Gaza Strip. North Korea claimed denuclearization. Robert Mugabe was reelected the president of Zimbabwe. And Hillary Clinton threatened to obliterate the country of Iran. So another thing that is unresolved is management came with iOS 2. And that brought us the introduction of EAS support and configuration profiles. So my first big iOS deployment, there were 10,000 devices, and we had to put them in the hands of people all around the world, which means we'd probably never see most of them again. And back then, the only management tool was this one. Anyone know what management tool this is? It's very enterprise ready. It was tailored. Back then, the only real management features were whether you encrypted or didn't encrypt your backups. And if you encrypted the backups, the settings were in there, the apps were in there, and if you didn't encrypt, they weren't. So Hotmail, this other enterprise-grade management tool, what we did here is the person who put all the apps in iTunes that we used for this deployment used their personal Hotmail address to buy the apps and to then install them in iTunes. And they got deployed to 10,000 devices that then went to all corners of the world. From there were updates to the apps. So guess who got about 10,000 password reset requests to their Hotmail address? That guy. But we learned a lot of information. We gave, I was subcontracting for Apple at the time, and we gave a lot of feedback to Apple on things that could make this whole iOS deployment thing better. And we got the first generation of management tools. This included IPCU, or iPhone Configuration Utility, and that looked something like this. Did anyone use this back in the day?
Oh, yeah.
It's right after lunch. Normally, no one raises their hand at lunch. Just for me. Will you guys do that again? Thank you. And then we got Apple Configurator shortly thereafter. And so whereas IPCU was mostly there for us to look at logs on devices and install profiles, Apple Configurator brought the ability to deploy apps. And basically, you exchanged app code, you bought VPP apps, you got codes that worked very much like gift cards for iTunes, and then you deployed devices with them. And those profiles, those look something like this. Is anyone unaccustomed to profiles? Everybody's pretty much mastered this part by now, probably. And then when they're installed, they look something like this. It's pretty basic. They can be programmatically created, thanks to Tim Sutton. Hi, Tim. And then they can be managed manually with scripts or third-party tools. And the first wave of these tools were like little apps that had buttons in the app, and you could, like Casper Remote, and you could hit a button in the app and install the profile on the device. And that was kind of the limit of centralized mobile device management, circa maybe 2007. One thing to keep in mind, all management was opt-in. So you could install these profiles, you could delete the profiles. Eventually we got the ability to set profiles as uninstallable or removable. And then came MDM. So MDM, has anyone ever seen a screen kind of like this one? So this is JAMF screen. I tried to make this very vendor agnostic, so you'll see screenshots from other tools as well as we go through. But basically, here you have a device talking to APNs, APNs talking to client devices talking back to APNs. The way this looks is when put into motion, you've got an MDM server, and then you've got that server sending a push notification to APNs. APNs sends a magic request to the devices, or a push magic, and then the device checks in with the MDM server, sees what the server's got, and the device sends back what it's got, or the server sends back what it's got for the device. And really, this was in response to Apple kind of wanting to rethink how management is done. What they didn't want to do is they didn't want to have devices binding to Active Directory or Open Directory or any other directory service, and they didn't want to have an agent that devices had to communicate with. In fact, one of the hallmarks of all of this is Apple never wants you to talk directly to the device, and that's just mobile security and the way that they architected this. And it works. It worked so well that other companies started emulating that and doing very similar things. This is a screen from Manage Engine, which is a cross-platform MDM solution. And here they've got Google Cloud messaging service working in much the same way APNs does. So the MDM spec. Has anyone read the documentation for the MDM spec? I regrettably have. And I've read every revision to it for the past 3 years, which makes me very happy. So before I dig into what is in the MDM spec, I was sitting with some developers doing some R&D stuff about 2 weeks ago, and one of the developers, I said something about the certificates, and he's like, it's always the certificates that are a pain. So why are certificates a pain? Well, we've got a bunch of certificates that we have to deal with. There is the Apple root certificate, which that's pretty easy to deal with. It's pretty much installed on every device by default. There's also a WWDR Intermediary certificate. That is for MDM to work. That's so that WWDR can do stuff, which is worldwide developer relations, without having to bug the sysadmins who deal with iTunes and all the other stuff. And then you've got the push certificate, the device-based DEP certificates. On your end, you've got your CA, your SCEP, and device-based non-DEP certificates. And the beginning of that chain is the Apple root cert. That's publicly available. URL's here. Feel free to download it, although it's already on all your devices. The WWDR cert, public key is also available. On your device, they look like this. There's your Apple cert, your root cert, and your WWDR intermediary. So these are pretty much basic certificates. It starts to get fun when you get into signing certificates. So the MDM signing certificate is used to establish a trust between an MDM vendor and Apple. These are obtained through an iOS provisioning profile or portal, and it contains public key, private key, and then some trust certificates. And they're used to sign a customer's CSR. They should be kept private, which with the word private in the name of private keys, I would assume is hopefully self-explanatory. And that's what it looks like on a device. So the CSR thing is kind of funny. And there's no API for this exactly, so basically all MDM vendors are supposed to have customers do this process. Any MDM vendor that's not having a customer go to the Apple portal, download a cert using a CSR is kind of breaking the rules and doing something funny on the back end, with the exception of Profile Manager, where Apple's actually leveraging their own internal private API for this. So the CSR is in DER. It's signed with the private key of the MDM signing cert. It's SHA-1, et cetera, et cetera. I'm not going to actually read a lot of the text on these, I would say I'll post this and then people can download it if you want to know more about some of this stuff, but there's about 115 slides and we're about 4 minutes late starting, so yeah. Or I could talk like an auctioneer. Would anyone like that?
Yes, I'd like to see you try.
Well, not gonna. I would say challenge accepted, but it's so not. So the push cert web request is a file that's downloaded by, it's posted on your MDM. You download this file, you go to Apple, you upload the file. It's just a basic CSR, and then you get a programmatically created MDM _ vendor name _ certificate.pem, which sounds really like I should be saying that super fast because that would be kind of awesome. And then once that certificate exchange has occurred, we can then start doing Apple push notifications. So the thing that, so the MDM protocol guide doesn't really talk about Apple push notification services. That's talked about in about 5 different guides. So in order to build an MDM or understand kind of the inner workings of an MDM, it's like there's 4 or 5 guides on building APNs services, and then there's one on the MDM protocol itself. And then it kind of helps to know about 3 or 4 other pieces of technology that Apple links to in those documents. So it can be quite a bit of reading. So all these certificates and APNs allow you to do this, which is that thing that you see when little red circles show up on apps on devices. Has anyone seen this weird thing happen? Couple? So the thing is, you don't see a little red circle because the app, the agent that these things are connecting to is called MDM client. And MDM client, has anyone looked at that on OS X by any chance? Run strings against it, tried to see what it's there for. Like Rich, written a defaults command that allows you to manage the com.apple.mdm client space. So this app runs in the background. You don't see it, so you don't see the little red dots that tell the device that it's got something sitting on the server waiting for it. Much like the little red dots show you that there's something waiting on the server for your mail client, your messages client, etc. One more certificate to talk about, device identity certificates. So these are used to encrypt profiles and or other communications that go to and from devices. Oddly enough, per the spec, you're not supposed to actually encrypt profiles before you send them, but some people do and can. Anytime a device checks in, it validates, the MDM validates that that device has a certificate, the device validates that the server certificate is good, everybody's happy, and then communication can occur. One thing here, DEP devices are bootstrapped with a certificate signed by Apple as opposed to a certificate signed by your MDM. And then your MDM's just told to trust that. How am I doing, Bryson?
How many slides did you say you had?
I'm good. Don't worry about it. Pick up the pace.
Pick it up.
Go faster. All right. So the APNs token is something else that any MDM is going to store in their database about devices. And this is a string broken up, sent in binary to the MDM, or to APNs. And it's stored as 32 binary characters. So with all these certificates, what could go wrong? Anyone?
Broken chain.
Broken chain, they can expire. Expiration's a bad thing. There's been a slew of certificate providers that are having security problems these days, causing reissues of certificates. Code signing certificates, if you use those, are about $800 a pop normally. So some of these things just cause problems. The other thing that can happen is, according to the type of CA you're using, it could go dark, it could be unavailable, things of that nature. Having said that, I see very few issues on MDM that are created by certs, except for when they weren't written right in the code. A very common question I get from customers is, why do I have to open port 2195? Anyone want to yell it out?
APNs?
APNs. So if all of this stuff is built on the foundations of APNs because they don't want us to reach out and talk to devices, and they don't want devices to automatically check in with the MDM without going through them, then suddenly that needs to operate on a port. What streams over that port? Anyone want to take a stab at this? Anytime the words big Indian show up, it's going to suck. I mean, I'm not going to lie to you. So this was a fun library to write. Basically what we're doing is we are taking this string and we're streaming it over SSL to Apple to create an APNs request. It looks kind of complicated, and it kind of is. But that happens over port 2195, and so that's why port 2195 needs to be open. It can fall back to 443, but everyone opens 443 anyway, so that's not a problem. So for more on APNs, I'm not going to dig in too much deeper. There's a link. I'm going to give you 2 minutes to write that down. Nope. So what if you don't open the ports? From a troubleshooting perspective, there's lots of little apps out there that'll tell you if a device can access the courier, the gateway, the feedback servers from Apple. You can use those. If you don't open the ports, nothing's going to work. The other way to test it is you can actually telnet into gateway.push.apple.com over port 2195. An important concept that I've had maybe 6 customers over the past 3 weeks where I had to have multi-hour calls about why they need to open port 2195, and this is quite frustrating. So I'm just going to give them a link to this talk from now on and not have that conversation. But this is egress traffic, and it can only go to Apple if you limit it to that port range. I would say one of the other big problems that we have with customers is they don't want to open something to an entire class A. And I can't say I blame them entirely, but this is egress traffic for one limited port, and the only devices that live out there are Apple.
Encrypted egress traffic.
And it's encrypted. I'll get more to the encryption piece in a minute because that's been another challenge. So port 2196, this is the feedback port. What happens here is we're just checking to see if a device still has a token. If it doesn't have a token, we can't continue to communicate with it because we have to put the token in every single APNs request we send. Devices talk back to Apple over 5223, which can also fall back to 443. Slide 60, Bryson. Thank you very much. And to test this communication, and most of those apps that test communication with Apple are really just doing what I'm doing here. So it's pretty straightforward. And if you're looking in your logs and you see an error 410, that just means that the device token is expired and needs to be renewed. And we'll get into how that happens in a little bit. For more troubleshooting on this stuff, there's another link. I will not pause 2 minutes this time. And then some of this basic stuff is outlined here. We don't go into detail about what we're streaming over those ports because it's kind of irrelevant, but this is a document that kind of outlines what needs to be open and what's ingress, what's egress, and where it's going to and from. Another tool that can help with this is APSCTL. This command you can just grep for MDM client and you'll see all the information about your status with APNs. In fact, you'll get too much information, so you'll need to grep more. So, about the encrypted thing that this APNs traffic is. So why can't I use my proxy server? Does anyone have an environment that requires SSL inspection? So you cannot inspect this traffic. What you could do is you could ask Apple to make their stuff less secure so that you can then inspect what they're streaming. But I'm pretty sure, because I've heard people ask, that Apple will then say nah or nee. And that's because of certificate pinning. In certificate pinning, there's hashes and there's all kinds of stuff that explains that explains why this doesn't work. I'm not going to go into detail on that, but this link for Blue Coat does. So a question I get a lot is that the same for all vendors? Yeah. There's one slide, see? It's going pretty quick. So what if I don't open ports to my MDM server? And this is where you start talking about ingress traffic. I have devices out there in the field. They're trying to check in. They can't. So nothing's going to happen. They will get the MDM client will get the push notification, but then the device can't reach back into the server. If the device does reach back into the server, what is it seeing? Has anyone written a webhook? Bryson? So the device would see something like this waiting for it on the server. Here we have install profile, and then we have this block of stuff. Does anyone know what that is? It's just some base 64 encoded string. Now the beauty here is none of this stuff goes to Apple. So Apple never sees the super, super secure stuff, like what you're restricting, what you're allowing. Most importantly, probably your certificates. They never see the SSIDs that you might have or the passwords for those SSIDs. No data goes through Apple. Did anyone ever manage BlackBerry Enterprise servers? One of the things I didn't like about doing that back in the day was that a lot of information was stored with BlackBerry or with Research in Motion, and all that data was in Canada. And you know, we in the U.S., we don't want our data stored elsewhere. No, actually, we don't care. You guys do, though, oddly enough. So, but that was always I never really liked that. And that's not the way it works for these devices. Apple doesn't want any of that. It makes their security easier if they don't have to worry about that. And so this is all just very transient data where we're just telling Apple that there's something, and then the device checks in, and it's pretty it works pretty well. So do I need SCEP? Does having an MDM solution require you to use SCEP? Anyone? No. That's something I hear a lot, and a lot of MDM providers will build in SCEP, but mostly it's to make our jobs easier. So a device uses SCEP to obtain a cert, and then communicates that cert back to us during enrollment. We could, and some vendors do, actually just create certs on the fly and not use SCEP to do this. So the SCEP requirement is per vendor. And as I promised, there are screenshots from other vendors. This is LandRev. They do not use a SCEP server on the back end because their developers like the way that they do certs better than the way SCEP does certs. And in some cases, you could actually argue that not having SCEP makes the solution simpler because there's less parts of the solution that can fall down and break. So one of the things that David asked me, I sent David a copy of this deck, and he was like, well, some context, because it was really all just code and bullets, but he was like, some context might help. So what if devices fail to enroll? What happens during this enrollment process? So during this process, the MDM check-in command happens. And what does the MDM check-in look like? That. Can it be done now? No. Okay. So basically what we're doing here is we're sending an Authenticate command. If I take that and I move it to a REST client, which is how we prefer to write code because streaming bits really sucks, or at least test things. What I'm doing here is moving the headers off into headers, and that way you can kind of focus on what's actually happening here. The thing that I want to point out on this slide is probably the topic. So if you see com.jamf.something, the reason for the topic is to try to help with threading, if that makes any sense. So we send this check-in and then use iOS console to view the transactions and see what's happening under the hood on the iOS device side. So you'll see an error code, and then the MDM protocol reference guide actually has a whole table of what each error code means. So on the MDM side, we just take that error code and run with it. So the check-in protocol involves 3 commands. The first command is Authenticate. And all this does is verify that a device can enroll. And we get some interesting information back with the Authenticate command. This is JAMF Now, and we get a product name, and that matches to a model ID. And this is pretty basic in the way most agent-based solutions work anyways. But all we get back from this is either a 200 or a 401. 200 means success, 401 means failure. And then we put the enrollment profile on the device, which tells the device to talk back to the MDM server. I skipped that slide apparently. So what if a device enrolls but then stops checking in to the server? We also have this token update command that's part of the check-in protocol, and this just says, if we see on the feedback service that the token is out of date, we can basically tell the device to send us a new token, and then it can check back in. Because if we can't have APNs, then nothing else works. It's all kind of a house of cards built on top of APNs. So the token update is pretty simple. You'll see this push magic. All this push magic is back in that APNs where we were sending MDM client a push magic. That's it. That's all it is. And 45 after. Okay, everybody stand up. Groan. Stretch. You just ate lunch, you're full, and now you can sit back down. Is anyone mad at me for that? That guy. All right, so the checkout command. So when you delete an enrollment profile or you unenroll, that's what this command is doing. It's still part of the check-in protocol, but all it is the topic, that thread, and the UDID of the device. Now, what happens if you just wipe the device? Then the MDM doesn't know that it's no longer part of the MDM and it needs to be removed from the MDM side. If you gracefully unenroll, then you're just issuing a quick checkout. And this command takes about 2 minutes on a REST client. I don't know why I didn't add it. So, can I change the URL of my MDM server? The answer is no. The reason is because all check-ins and all other MDM commands go to that server URL. The server URL is unalterable in a profile. So if you do change that, then you would just need to reroute DNS or do some kind of port fix to make it work. And that's the same on an iOS device. On an iOS device, you can also see the check-in URL. So the check-in command uses the check-in URL, and the server URL uses, or all the other commands use the server URL. One interesting thing about this is almost every MDM provider, because we weren't given a spec on how they wanted this URL structure to look, will use something different. So for example, here we just see MDM/server URL, because that's how Zach and Ryan, the guys who wrote this part of Casper, decided to write it. AirWatch uses a different URL string. Profile Manager uses a different URL string. Some are longer, some are shorter. As long as they're legal URL characters, you can use whatever you want. So commands. Activation, I'm using a few as examples here to just kind of show how it works. I didn't really want to go into every single command because we don't really have time for that. So activation lock bypass. Here you've got a command, which the technical thing is escrow key unlock. And here's what it looks like in FileWave. In FileWave you have this little disable lock or activation lock bypass, and you have disable activation lock. You hit that button and you disable an activated, a lock-activated device. On the back end, this is all that we're running. It's actually pretty simple. Most of these fields are coming out of our database. If you notice, though, the URL is deviceservices-external.apple.com. So this is one of the very few places where we're sending something that we might consider secure through Apple. We're sending that activation lock bypass code to Apple in this JSON. One point that I'd like to make on this is xadm-auth-session. So you know how when you go to a website, you don't have to enter your password every time you load a new page for the website because you have a session token on that website. That can expire over time, but that's the initial. Every time we send a command, we can thread those commands with these session IDs and keep a persistent connection to Apple. Inside that, we can also lock it and say only allow this session for 30 minutes or 30 seconds, more than likely. Now, that code in that command, oh, by the way, one more. So if you look at the end of that URL structure, escrow key unlock ampersand serial. So there we're sending the command, and then we're defining what devices are getting the command with the rest of that. And then down here, we're actually adding any other attributes that are required for the command to process. So if you were to put that in like a bash perspective, think of the URL, escrow key unlock, part of the URL as being the bash command, and then think of like escrow key as being an operator, and then any of the other objects in there as being other operators to that command. And how do we get that code? So the reason I wanted to use activation lock bypass in this one is because at enrollment of a supervised device, you get the activation lock bypass code as a variable that you get back in your JSON. So it's obtained at enrollment, and only if it's a supervised device. You can supervise a device, for example, in Apple Configurator if it's not a DEP device, and then you can enroll it, and we'll get that code. It only issues that code at supervision. So if you have a device that's enrolled and you lose a table in your MDM solution, then you'll have to re-enroll the table that has this in it. You'll have to re-enroll all your devices, which on unsupervised devices means you'd have to wipe them all. Which you can do with one button. I mean, you just select all the devices in an MDM, hit wipe, and they all disappear. It's really a wonderful thing to do. Luckily, Tom accepted some phishing emails that I sent him earlier, so that's on my short list of things to do later today. So settings. So there's a settings command as part of the MDM protocol, and I used micro MDM here because I like the way that Go lays these things out. So if you were to go here and just look, you'll see all the settings. Now these are different than things that are in profiles. So for example, voice roaming setting. That's a setting that you apply immediately to a device that can then be changed. And these are, think of them as the once in a discal type of environment, as opposed to an always, which is most profiles are always, if that makes sense. So profiles, I decided to use AirWatch to show these. If you notice, it's just a list of checkboxes, and when we send this, we convert these intoplists and send an install profile command to a device. We don't send the command to the device again, we send the command to APNs. APNs tells the device to check in, the device checks in to a webhook that we have running waiting for the device. And most of these screens for most vendors look the same because Apple used to have a style guide that they wanted us to conform to in order for us to be allowed to still have our MDM signing certificates. Delete profiles is another command here. You see the URL, which is just devices. And then in the header, you see a delete command. And then you have a list of devices. Now here I forgot to include the ampersand of the basically the GUID of the profile that I wanted to delete, but you can kind of get the sense that this is how all of this stuff kind of works. And the reason that I use my REST client for a lot of this is just to show that, like on the MDM side, once we get all these crazy certificates and URL structures worked out, it's really quite simple. Like each section of the MDM protocol guide, you just need to write one of these. What gets hard is to figure out, well, what's a setting versus what's a profile versus what's actually just straight up not allowed. And then Apple continually releases new features. For example, one day they decided to let us set the background of a device, and so we had to build in a feature that does this and put this behind a button. So you click a button in software, we query the database, get the variables we need, and then send a JSON packet out like that. So does the MDM inventory contain app information? Yes. So this is one of those funny places where I was told no. And the reason I put this slide in is actually, so I was a consultant, and I didn't have access to the MDM protocol reference because Apple hadn't opened it up yet. And then I came to JAMF to write Bushel, or help write Bushel, and we wrote it, and I got to learn all this stuff, whereas it was behind a screen. It was obfuscated from me before. And so I had to rely on trusting what other people told me about some of these things. So I asked Apple, and asking Apple is a very large thing because there's tens of thousands of employees. I asked people at Apple, multiple people, does the device tell me when I ask, as an MDM, all the apps that we did not install on the device? And everyone told me, definitely not. No, that's a huge privacy concern. Once I got there and I started looking at the the payloads that we get back, I'm like, well, there's the entire set of apps right there. Whether or not the MDM provider chooses to put that in the GUI or expose that, or even commit it to a database, we do get that back. So, and the reason that this came up is because I had a bunch of customers who were concerned about privacy. For example, if one of my employees goes to an AA meeting and I fire them the next day, and they have that AA app on their device or NA or whatever, am I liable potentially for something around that? And the answer is basically yeah. So VPP, who wants to talk about VPP? No, that's not enough people. That's better. All right. So VPP works by we install an S token in the MDM. The S token links the MDM to Apple's iTunes service. And Apple's iTunes service, which is different than Apple's MDM service, then allows us to send REST commands in much the same way that we've been sending REST commands already. So what's in an S token? So an S token is a file with .s token at the end usually that looks like this. You can run this command and you can see what's actually in there, which is more encoded information. And it's funny when you use the words encoded versus encrypted, you know? But there's more information in there, which is a string that links you to them, an expiration date, and a org name. Normally what I try to do on the MDM provider side is parse this so that I then get the expiration date and can tell my customers that, hey, your VPP token's about to expire. The VPP service, it's mostly per device and per user. We're trying to desperately to move away from codes and things of that nature. If Apple had their way, I think they'd move to a pure per device model and away from per user entirely. And as an MDM vendor, I can say that the logic and coding around the per user thing sucks. So I would love to do that as well, but a lot of people do per user. So some places buy 10,000 copies of free apps. Why does this matter? Because we get information about every single thing when you link it. So we had a school district who had bought 10,000 copies of all the free apps that they used, because someday Apple might start charging for them, or the vendor who makes them. And on the MDM side, we then had to process all that, which took like 8 days, and their JSS ran super slow during that process. because it's syncing all the information back, and it can be quite a lot. This is important. For privacy, the VPP endpoint doesn't know which user is which. So again, Apple is desperately attempting to protect the privacy of end users of devices. That's why we can't communicate directly with a device. That's why most of the stuff is opt-in. So I've seen some of the craziest iTunes email addresses out there. And if you have one of those crazy ones, Apple doesn't want your employer to know that you're hotguy89@gmail.com or something. So they obfuscate that. The MDM vendor, we get a hash back. So when you get to coding this, basically what you're doing is you're saying, okay, I have a hash, and this is a per user enrolled thing, so I'm going to send this app to all 8 devices that this user may own, or all 3 devices this user may own. And when the last user, or when the last device unenrolls, then I'm going to reclaim that app license so that it's available for someone else. It's kind of hard to keep track of because you're just keeping track of these hashes. Per device is much simpler. Hey, I pushed an app to a device. It's there. You know, according to if users have 2 or 3 devices, it can start to get more expensive that way, of course. And then I mentioned if the service isn't available, a GUI might go unresponsive. I didn't include any source code here, but these are some endpoints that we wrote to sync the entire iTunes library to JAMF Now. And the reason we did that is because in the GUI, we're saying, oh, well, show them a list of all the apps that they own. But you don't want to show a bundle ID of apps, so you're showing them the name of the app, which you then have to translate, and you have to do that with a call to the iTunes Store. You don't really want to do that because sometimes the iTunes Store isn't actually available from an API standpoint. So we wrote in this whole piece of logic, and we used the iTunes API in order to sync the contents of the store, which was fun. And when I say fun, I think I have a very different definition of fun than most people, maybe. Does that sound fun to anyone?
Minnesota fun.
Minnesota fun. It snows a lot, dude. So, who wants to talk about DEP? That's what it looks like. We don't have time for that. So, so best practices. Make sure to open those ports. We talked a lot about ports, 2195, 2196, et cetera. If people don't want to open them, they can't use APNs, period. MDM will not work. Use Profile Manager for comparison testing. So who's downloaded the latest builds of the next version of the operating system? So the OS X server builds actually have Profile Manager, which has a whole slew of new stuff that will be available by MDM providers by the time that OS is released. And that's what we're testing against. So as a developer, I might open up, when I'm wearing my developer hat, I'm no longer a developer, I sucked at it. But as a developer, the protocol reference guide doesn't have everything in it. So we might say, oh, well, let's run this through Profile Manager, and then we'll extract those profiles and look at it. This is also true, like in a lab at a big company, you might have a Profile Manager server so that if your MDM provider, whoever it happens to be, doesn't work when you tell it to tell the device to do something, then you can test it in Profile Manager and see if that's expected behavior. If it works the same in Profile Manager as your MDM provider, then it's a really great reference tool for testing this stuff. It's also great for making profiles and installing them manually, which is another big troubleshooting technique. No profile conflicts. So if you're managing the domain, the restrictions, let's just call it, you only want to manage restrictions from one payload. If you have restrictions managed in 2 different payloads in MDM, then which one is going to win? And Ben? Undefined. And by undefined, we mean completely chaotic. Some domains will actually process based on alphabetical. Some will base on least restrictive, most restrictive, etc. So the next best practice, who's enrolling? So this is an OS X thing. If a user enrolls a device, it's very different than in iOS. The user who enrolled that device gets all of the settings coming from the MDM. If another user then tries to enroll the device, it creates a race condition on the device, and the MDM client throws up and can't operate anymore. So throw up, by the way, is a big technical term. It's very important. Another best practice, use libiMobile device. Anyone used it? When it comes to iOS management and when it comes to getting extremely verbose logs, this tool is probably the best. You can programmatically pair, which means you can start doing automated QA testing, and it's a pretty helpful little tool. Self-gratuitous link to my website. And then here's some more resources. Again, I will post this, the slides themselves, so you don't have to write these links down. But if you choose to, I will give you about 15, no. And then we have no time left for Q&A. I may or may not have timed it that way on purpose. But thank you all for coming and listening, and apologies for going 4 minutes over. So, thanks.
Any questions? Don't listen to Charles.
DEP,
One
Yeah.
second.
If there are questions, I'm down. Oh, so DEP. That's fun to write code against. You guys go have fun. We'll see you in 10 minutes of the next session.